Hey guys, Nacho here. In today's video we are going to learn how to create 3 mobility mechanics in Unreal Engine 4 using C++. And as I said, 3 mobility mechanics, and those are going to be dashing, sprinting and double jumping. So let me show you the final result. We are going to start off with the sprinting mechanic. So here you can see how fast I walk normally, and then when I'm going to press left shift I'm going to run. So as you can see I'm going to walk a little bit faster. And then there's going to be the double jumping mechanic, so simple double jump, right, which is going to get resetted once I'm going to hit the ground. And if I'm going to press jump multiple times, it won't work. Right, and then there's the dash mechanic. As you can see, you can dash mid-air, you can jump, dash, and jump once again. And this is what we are going to be creating today in C++. So the first thing that we are going to do before starting encoding, we are going to go to Edit, Project Settings, and we are going to go to Input. In here we are going to create 2 new input actions, because one of them is already here, that being jump. So we don't need to create another one. So the first one is going to be sprint, bound to my left alt, actually left shift, and then dash, bound to my left alt. Okay, and now we are going to be able to code. And what we'll have to do is to open the C++ class. Okay, so now that Visual Studio has loaded, we will need to go a little bit into here to set up player input component. And we are going to take a look at the first line right here. Player input component bind action jump, i.e. pressed this and a character jump. So let me explain what this does. We are going to access the player input component and we are going to bind an action. So basically we are going to bind what binding an action means is that when a specific key is going to be pressed, a function will be called. So when we are going to press a button which is contained by the jump action, and for us that is going to be spacebar, we are going to fire this jump function from a character. But when do we want to fire that? When we press or when we release it? For us that is going to be pressed, because here we are going to specify IE pressed. And this is for the character that we want to bind this for. But the thing is that this a character jump function is not going to work for our double jump. So what we'll have to do is to go into the header file and create a custom one. So in here I'm going to get ufunction, and I'm going to get 2 parentheses. Then I'm going to get a void, and I'm going to get double jump, parentheses, and semicolon. So let me explain. The ufunction keyword here is going to let us use specifiers such as blueprint implementable event, so we can make this function in C++ but set it up in blueprints, or blueprint callable, so we can call this function in blueprints even though it's created in C++. And there are many more. I'm going to leave a link down in the description of this video where you can check out more specifiers. Okay, so now that we have our void double jump created, if we are going to highlight over the name, you can see here function definition for double jump not found. To fix this, we are going to press Alt plus Enter, and we are going to create definition of double jump in mobility mechanics character.c++. We are going to switch back to our C++ file, and in here we are going to need to set up the function, because right now it has no functionality even though it's created. So what we'll do is to create a new variable, and for this one we are going to type u property parentheses integer double jump counter and a semicolon. So the u property does basically somewhat the same thing of what ufunction does with specifiers. We can set here edit anywhere, so we can edit in the editor, or we can set blueprint read write, so we can get and set the value of this variable in blueprints. And there are many more as well. There's going to be a link in the description of this video with a link to some more specifiers. Okay, now that we created our integer, we're going to go into the C++ file, and we're going to check here if double jump counter is less or equal than 1. And maybe you notice that we haven't set the double jump counter value, and that is because if we haven't set it up, the compiler will know that we meant to set it to 0, so there's no need for us to go into the constructor and manually set it. Okay, and then we are going to set this if statement. So if double jump counter is less than 1, we are going to go and launch our character. So a character. Okay, and we're going to launch character. And in here, what we'll have to do is to make an F vector. So if you actually take a look here, void launch character, F vector launch velocity, bool be XY override and bool be Z override. So basically we are going to access the A character class and we are going to search for the launch character, which is going to basically launch our character in a direction for a specified amount of units. And here you were able to saw that we have some arguments that we need to set. So that is going to be an F vector and two booleans. So to set the F vector, we're going to get F vector and we're going to get two more parentheses which are going to create a F vector, and we will need to set the axis. The first axis is going to be the x1, which is going to be 0. The next one is going to be y, 0 once again, and the last one is going to be the axis upwards, which is what we want to set. So for this one, we could go in our header file and create a new float value. So u property, parentheses, and we're going to have here a float, and let's say jump height. And now for this one, we're going to actually go into our constructor and set a value. So jump height. Okay, jump height equal to 600.f and a semicolon. This means that this is a float. Okay, so just making sure that this is working. One thing we can do to edit this right in the editor, as I said, we can add here edit anywhere and eventually blueprint read write. Okay, so now by default this is going to be 600 and we are going to put here jump height. Okay, and then we are going to, after the closed parentheses, the first one, we are going to put a comma, which is going to make sure that we ended the first parameter, and now we're going to go on the second one, and this one is going to be boolean bxy override. That means if we want to replace the x and y velocity, and we don't want to do that because we are only going to jump. And then for the bool bz override, which means that we're going to replace the z override, which means upwards, we are going to set this to be true. Okay, and then we're going to put here a semicolon. Then what we'll do is to get double jump counter, and we're going to increment this, so plus plus and a semicolon at the end, which means that after we are going to jump, we are going to set the value of our double jump counter to be is value +1. Okay, and basically this means that we can jump only 2 times. The first one being 0 is going to be set to 1, and then this is still going to be less or equal to 1. Alright, but there is currently one problem that we need to fix. If we are going to double press spacebar, we are not going to be able to jump anymore after that. And that is because we never reset double jump counter. And now let's see how we can do that. We are going to go over on the header file in protected, and in here we are going to type virtual void landed constant f hit result hit, and then we're going to type override. So let me explain. This function landed is a function that was first introduced in the character header file, and we want to override it because we want to set a custom functionality. So let's go and do that by pressing Alt and Enter and create definition of landed. And now let's switch over to our C++ file, and in here we are going to set double jump counter to be equal to 0. Okay, and now we will need to use this code. In order to do that, we are going to go to our player component, player input component, bind action, and here instead of a character jump, we are going to press Shift and 7, and we are going to get a mobility mechanics character, this one right here. This name will depend on the name of your class. Okay, and now we are going to need to specify a function, and for us it is going to be double jump. And now usually when you're going to call a function, you will need to put parentheses right here, but we cannot add arguments or parameters when we're going to bind an action. Okay, let's save and let's compile and see what's going to happen. I'm also going to show you that you can set the jump height manually in the editor. Usually the first time it's going to take a little bit more because it has to recompile the entire code, but then it should be pretty easy and fast to compile. So now it compiled, and as you can see here, jump height 600, and you can set it up however you want. Let's play. And now as you can see, I was able to double jump, and now I'm able to double jump once again. And if I'm going to press multiple times, I'm not going to be able to do it more than twice. And now let's go on and see how we can set up the sprint mechanic. Okay, so now as I said, we're going to set up the sprinting functions. So we're going to create two new functions. U function void sprint. Okay, and U function void walk. Okay, no arguments in neither of them and no specifiers. And also the sprint one is going to set the running speed and the walk is going to set the walking speed. So let's create declaration or definition for both. Okay, so alt enter as I said and create definition. And I will need to head up over our C++ file and set up some things. So first we will set up the player input components. So player input component bind action. For me that is going to be sprint. We just set it up a little bit before in the video in the input part from the edit project, i.e. pressed. Okay, and this, so we're going to bind this action for this character, and we're going to get ampersand a mobility character, and the function is going to be sprint. Okay, and I set my column, and now we can copy this or duplicate this line of code by pressing Ctrl and D, right? And now instead of IE pressed, we are going to set IE released, and here instead of sprint we are going to set walk. So now when we are going to press the button specific to the sprint action, we are going to start sprinting, and when we are going to release it, we are going to stop sprinting. That means that we are going to start walking. But in order to set the maximum walking speed, we will need to access the player component movement. And to do that, we will need to include a new header file, and I already have it here. So include runtime engine classes game framework character movement component.h. And I'm going to leave a link down below from where you can copy this from the documentation. And now what we'll need to do is to go over our sprint function, and we will need to get character movement. Okay, parentheses, because this is going to be a function, and from here we want to set max walk speed. Okay, we're going to type equal and a semicolon, and we're going to copy this and set and paste it into our walk function. And here I'm going to create two new variables, one for the speed value and one for the walking value. So u property, no specifiers, and it's going to be a float, so float walking speed, and I'm going to copy and paste it once again, and it's going to be running speed or sprint speed, however you want to call it. And actually we can add here edit anywhere, so we can edit this in the editor. Okay, and now I'm going to go over the constructor and set the default values. So walking speed by default 600.f semicolon, and running speed by default should be 1000.f semicolon. Okay, now here max walk speed for sprint is going to be running speed. Okay, and for the other one, walking speed. Okay, now let's go and compile. So I'm going to hit compile, and now we are going to wait a little bit once again because it has to compile the entire code that we just wrote. Just completed sprint, actually speed. Okay, and here you can see walking speed and running speed. Let's play and let's see if this is working or not. So this is the walking speed right now. I'm going to hold shift. As you can see, I'm a little bit faster, and then when I'm going to let it go, I'm going to be a little bit slow. So this is working, and now the final mechanic that we are going to create is going to be the dashing one. Back in our header file here, we're going to create a new u function, so a void called dash. And let's also create some other variables that we might use later. So u property and I'm going to set this to be edit anywhere. Okay, and this is going to be a float dash distance. Okay, another U property, edit anywhere, float dash cooldown. Okay, and another U property, which will have no specifier, called boolean, which is going to be a boolean, and called can dash. So first, let's set up the default values for each of them. Can dash should be true every time. Then dash distance is going to be 6000 by default. Dash cooldown is going to be 1 second by default. And also we'll need one more U property, edit anywhere. Okay, another float and dash stop. We're going to use this later, and I'm going to explain it then what it means and what it is going to do. So dash stop equal to 0.1f. Okay, so now let's set up the player input component so we can actually use the dash function. So player input component. Okay, bind action dash, we created it earlier. Okay, then IE pressed for this, and ampersand a mobility mechanics character, and we're going to have here dash. So when we are going to press the button specific to the dash action, we are going to call the function dash. Okay, so we need to create the definition of the dash function. So let's go in the header file, alt plus enter, create definition. Okay, let's close this and go in the C++ file. Here the first thing that we have to do is to check if we can dash. If we can dash, so it is not on cooldown, we are going to do the following. First, we're going to get, once again, get character movement, and we are going to set breaking, let's see how it was, breaking friction factor, and we will need to set this to be 0. And that is because we don't want to get slowed down by the ground if we're going to touch it or anything. This is what this does. Then we are going to launch our character, so launch character, and here we'll need to construct a new f vector. Okay, and before creating that, we are going to set the following booleans, so the overrides, to be true, because we want to replace all the velocities. Okay, and a semicolon at the end, don't forget about that. And now let's see, we are going to get follow camera, that is the camera that my third person character is using, and we are going to get forward vector, and we are going to get here only the x axis. Then we are going to get a follow camera once again, get forward vector, and this is a function, so don't forget about the parentheses. Okay, so get forward vector, point y, and then the other one is going to be 0. Okay, so basically we're going to have here a vector that is going to have the x-axis to be the forward vector, to be the x-axis of the forward vector, the y is going to be the y-axis of the forward vector, and then the z is going to be 0. And that is because if we are going to point upwards or downwards, we don't want our dash to be affected by that as well. We always want to be able to dash only to the left and to the right and in front, but not up and down. Okay, and then we're going to have here a f vector function, which is going to be get safe normal. So what it does is that is only going to extract the direction of this f vector instead of getting the entire value. So basically it's going to keep the direction but set its value to be 1. And you could also use normalize, but normalizing is going to set this as well. So it's going to set the forward vector to be 1, and basically everything that we have in here is going to be set to 1, but the get safe normal is going to get a reference to these. Okay, and there's no arguments in here, and then we will need to multiply this with a dash distance. So we are going to get the direction, and then we are going to launch our character in the direction for a specified amount of units, that being dash distance. Then we are going to set can dash to be false, okay, because we don't want to be able to dash that fast. And then we will need to include a new header file, and that is going to be runtime engine public timer manager.h. That is because we are going to set up some timers, and timers basically are delays in blueprints. There's no workaround for delays. I mean, this is kind of a workaround for delays in C++, but there's not a way to type your delay and then type here the amount of seconds you want to wait. So we are going to create a new function, because we will always need to use function with timers. So you function, I'm going to call this, so it's going to be a void and call stop dashing with no arguments. Okay, and then we will also need to create a new U property, and that's going to be an f timer handle, which is going to basically be the handle of our timer. You are going to meet this in blueprints as well. I'm going to call this unused handle. Okay, now let's create the definition of stop dashing, but we're going to set it a little bit later. First, we're going to set here the timer, so get world timer manager parentheses dot set timer, and now parentheses once again, and the in out handle is going to be unused handle. Then we are going to need to type this, so for this character ampersand, this is going to be the function, so a mobility mechanics character stop dashing. Okay, no parentheses. Now we will have to set how much we want to wait, and that is going to be dash stop, so the one that we created, and false because we don't want to loop this. So this boolean is going to choose whether we want to loop this timer or not. So basically after 0.1 seconds we are going to call this function called stop dashing. And now what we'll have to do is to once again get character movement and call stop movement immediately. Okay. And now let's copy the get world time manager, basically this entire line of function, because we will need to set a new function once again, a new timer, and it's going to be dash cooldown. Let's create a new function once again. So this is going to be reset dash. Okay, create declaration or definition, and now let IntelliSense make its stuff. Okay. And now in the C++ file, here we are going to set can dash to be true. Don't forget to replace the stop dashing here to reset dash. Okay, alright, so now basically we are almost done. The last thing that we have to do is to get the breaking friction factor and set it back to 2, the default value. And now let me re-explain everything in here. So basically, once we are going to press our left alt button, because that's what I used in my project, so the dash one, we are going to set the breaking friction factor to be 0, so we are not going to get slowed down by walls or floors. And then we are going to launch our character in the forward vector based on the dash distance, so this is how much we are going to dash, and we are going to replace both velocities x, y and z. Then we are going to set the can dash to be false. We are not going to be able to dash anymore before the cooldown is going to run out. And then after 0.1 seconds, that being the dash stop value, we are going to call the stop dashing function, which is going to stop the movement immediately. So so all the velocities are going to be set to 0. Then we're going to set the breaking friction factor back to 2. And then we're also going to set a new timer, which is going to call this function reset dash after the dash cooldown is going to run away. So it is going to set the can dash to be true once again. So hopefully my explanations were clear enough so you understood. Now let's compile and let's see if this is working or not. And let's see dash dash distance 600, dash cooldown 1 second, and dash stop 0.1. So left alt, and as you can see it is working. And if I'm going to dash on the ground, I'm not going to get stopped by the floor and neither by the walls if I'm going to go along them. So this is pretty much everything for today's video. I hope that you enjoyed it, and if you did, don't forget to leave a thumbs up to let me know that, and also tell me in the comments below what did you think about this. I'm really looking forward for your feedback. I want to start making more C++ tutorial, but blueprints as well, and perhaps combine them to be able to deliver content for both blueprint beginners and C++ beginners. Also, if you're new to the channel, don't forget to subscribe to stay up to date, and if you wish to support me, you're going to be able to get the project files for this tutorial. That being said, thanks for watching, and I'm going to catch you in the next one. Goodbye.